Okay, we're going to continue looking at Chapter 2. I stopped, I believe, at this slide. It might have been the slide afterwards, but it's where we're going to start up again. Measurement is a human endeavor, and as such, it's fraught with error. And in terms of research, we talk about error as two different types of error. We talk about reliability, which is random error, and validity as systematic error. And visually, this is we can think of it as this way. Reliability has to do with consistency. So if you were to shoot at a target, this is a good analogy of a measure, and I guess your shotgun would be your measure at a reliable measure, because all your shots are consistent. The next one, you can see the shots are just all over the place. So in our analogy, we would say that this shotgun is neither reliable or valid. And in this, on the third one, on the far right hand side, we see, just as the first ones, the shots are reliable, they're consistent, but they're also accurate or valid. So this is an example of a valid and reliable measure. When we talk about validity and reliability, a lot of times we measure that using the R statistic. And it's called the correlation coefficient. And what the correlation coefficient is, the index of a linear relationship between two interval variables. And our statistic ranges between -1 to +1. The sign of the number indicates the direction of the relationship, and the absolute value of the number represents the magnitude of the relationship. And any R close to 0, approximately 0, indicates that there's no linear relationship between variables. Okay. So let's look at some examples. We want to look at some that have an example of a positive relationship. If we were to look at the first one, this one may have R equal to 0.8, for example. This shows the two variables it's looking at. The relationship between is the level of client satisfaction and the fit between the client and practitioner goals. So it makes sense then that there should be a positive relationship there. The better fit between the client's reason for seeking help and the service goal formulated by the practitioner, the greater the client satisfaction. If the client's goals and practitioner goals there's not a good fit there, then there would be a low satisfaction. So that's an example of positive relationship. Another common example is, let's say if we look at depression and anxiety, R equal to, let's see, 0.175, for example. That would be an example of a positive relationship, because as you would expect, as depression would go up, also anxiety would go up. And as depression would go down, anxiety would also go down. Okay? Next example, a negative relationship. And the example shown here is the level of, there's a negative relationship between the level of family stress and family income. So you see this slope. This is a negative relationship. So you'd have like an R equal to 0.92 maybe. R equal to negative 92. So as the level of family stress, as family income goes up, stress goes down. As family income goes down, family stress goes up. So the lower the family income, the higher the level of family stress. Another example, if we look at depression and self-esteem, there's a negative relationship between depression and self-esteem. Maybe that's R equal to negative, maybe just making these numbers up, negative 5.2. So as depression goes up, anxiety goes down. As depression goes up, self-esteem goes down. As self-esteem goes up, depression goes down. So that's another example of a negative relationship. Here's their example of a curvilinear relationship. They're looking at the relationship between the degree of skepticism about the value of social work research, and looking at the relationship between that degree of skepticism and the number of research courses taken. And what they're proposing is that's not a linear relationship. If you did an R statistic, it would be around 0. There would be no linear relationship. It would be a curvilinear relationship, in that skepticism decreases as students take more research courses up to a point, but after that skepticism increases as more research courses are taken. I don't know if this is true or not. This is an example given. It's sort of, I think it may be true. The more you know, the more skeptical you become, and the less you know, maybe the more skeptical you are. And there may be this point in the middle where your skepticism is low, where you maybe know enough to be less skeptical. So let's talk about reliability first. Reliability, the key word here is consistency. Consistency when repeatedly and independently measuring the same people or things under the same circumstances. There are different methods for determining reliability that we're going to talk about today, and we'll talk about the first 4, and when we talk about standardized scale, we'll talk about the standard error measure. But the first one, test, retest, reliability, talks about the consistency over time. So let's say you independently measure the same people with the same measure under the same circumstances. Okay, for example, on October 1st, I take the Beck Depression Inventory, and I take 50 people and put them in Roger Stout 2:25 at 5 p.m. one Monday evening. It's a Monday evening. Okay? Exactly a week later, I do the same thing with those same people using the same measure, the SOWK depression inventory under the same measure. Roger Stout, 2:25 at 5 p.m. Just a week apart. And then we take those two scores, we take the scores taken on 10-1 and then a week later on 10-8, and we do a correlation. And that correlation, if we have test-retest reliability, that correlation should be high. Now this is assuming that this group of students, or this group of people, I'm sorry, didn't undergo, some of them probably have had events that made them more depressed or less depressed, but on average, they didn't go through an event together or that made them more depressed. So, for example, it probably wouldn't be a good idea to do this the week before school started and then the week after. You'd probably find higher depression scores the week after school started. But assuming similar depression rates a week apart, then the measure should have good test-retest reliability if our R statistic is high, if it's probably 0.8 or higher. Alternative forms. This talks about a consistency over two comparable multi-item measures of the same construct, okay? Where you independently measure the sample, that should be the same people with two different comparable multi-item measures under the same circumstances. Let's say I go out and over the course of a couple years, I developed two depression instruments, depression scale number 1 and depression scale number 2. And I believe that I've taken great pains to have them have comparable items on each scale. So the way we would set it up, on October 1st, I would administer those scales one after another, and maybe for the first half, maybe for half the people I would have them do number 1 first, and for the other half I would have them do the second one first to work out, to make sure there's no order effects. But so we have scores now from two different similar depression scales, and we take those scores and we correlate them. And to the extent that the correlation is high, you have alternate forms reliability. Frankly, you won't find this in the literature a lot. It's not done a lot. You don't see two versions of the same instrument a lot. You might see it if you're going to give somebody an instrument every day and don't want them to remember what's on the instrument, or that kind of thing, because it's normally recommended that you give standardized instruments about 1 week apart. But frankly, you probably won't see this one in the literature a lot, but you will see test-retest reliability, and you definitely will see internal consistency reliability. And what I like to say is this is how the items stick together. This has to do with the homogeneity of a set of items. It's the consistency over multiple comparable items within a single multi-item measure. So it's looking at consistency among the items. So independently measuring the same people using a single multi-item measure under the same circumstances. So on 10.1 we give the Beck depression inventory, or let's say a depression inventory that I've developed. That's 10 items, and then we'll talk about reliability analysis. There's a when you do a reliability analysis, you get an internal consistency, and it's a way to identify bad items, and bad items drag down your internal consistency measure. But if that gets you off, ignore that. The way we measure internal consistency reliability, the first way is called split half reliability. And what we do is we divide the items in half. So if it's a 10 item measure, we use items, and we have 50 people. We divide them in two separate halves. So items 1 through 5, and then we take items 6 through 10, and we take the score from 1 through 5, calculate that, and calculate the score from 6 through 10 for these 50 people. So the score is computed for each half measure, and we do a correlation between those halves. And that's how we would calculate whether or not we had internal consistency. Now you could divide them in many different ways. You could do odd versus even. You could randomly pick 5 and then take the other 5, and so you can see, hopefully see that the best measure would be a combination of all possible split halves, and that's exactly what coefficient alpha is. It's equivalent to the average of all possible split half coefficients. So if you had 10 items, you could come up with, I don't know what the number is, but whatever the number is, possible ways that you could divide those 10 items into two different halves. You would take the average of all possible split half coefficients, and that's coefficient alpha, and that's usually represented by, it's a little fish symbol. Should draw it on here. Usually I have my board, but it's a little fish symbol, but it's a type of R statistic. And you will see this. This is a very important correlation. And if you don't have, it should be at least 0.7 or above. You usually see good scales, 0.8, 0.9s. Okay? If you do a reliability analysis, let me switch back. If you do a reliability analysis on SPSS, and that's how you find out what your internal consistency is, for each item it will tell you what the coefficient alpha is if that particular item is omitted from the scale. So if you're looking down and you see 0.8, 0.9, 0.8, they're all in the 0.8, the 0.83 or 0.84, and then suddenly, you see a 0.93. Suddenly your correlation coefficient goes up a point. Then that item you may want to consider dropping, because that item doesn't stick together with the rest of them. For example, if you had a bunch of depression items and you stuck an item in there that says, I love motorcycles, and you gave that to a bunch of people, my guess is you would get an internal consistency of probably 0.7. And if you did your reliability analysis and you looked at I love motorcycles and looked at the correlation coefficient, the coefficient alpha without I love motorcycle item being in there, it would be a 0.85. It would be dramatically higher because that item didn't stick together with the rest of the items. So that's all I'm going to say about internal consistency. The last one we're going to talk about in terms of reliability is consistency across observer. This comes up when we talk about behavioral observation. We'll talk about this a lot. But this is where you have multiple observers independently observe the same people using the same measure under the same circumstances. For example, you might have two parents independently observing their child. If you had it in a laboratory situation, you might have them behind glass, or you could have it in a home situation. Independently observe their child, and they would note, using the same measure, the number of dysfunctional behaviors, and you would define what those were. And that's important that you would define that. And the way that would get measured is you would use one way is percent agreement, the percent of the time that the parents agreed, kappa statistic, which is mostly what you see in the literature, it's the most accurate, or visually. You could have the child's problems rated by mother and father. Here you have the number, the child's problems always on the dependent variable, always what you're measuring on the vertical axis, time always on the horizontal axis, and you can see that there's some consistency, but the father consistently sees more problems than the mother. So this is, probably this isn't realistic data, but it's just an example of how another way you could look at inter-observer reliability. Standard error measures, like I said, we'll come back to this when we talk about standardized scale. Adequate reliability, these are the guidelines, but I wanted to point out on page 44 that these can vary by different types of reliability. But in general, 0.7 and above is acceptable. Validity. Reliability has to do with consistency. Validity has to do with accuracy. It's whether or not a measure measures what it is intended to measure. Whether and how well a measure measures what is intended to measure. It is more important but more difficult to determine than reliability, because as we showed previously, something can be consistent in that little shotgun thing. So a measure can be consistent, but that doesn't mean it's accurate. So again, there are several methods for determining validity. We'll talk about each one of those. Face validity. This is very easy to understand. Face validity just means to what extent does a measure appear to measure what it is intended. So it is basically what, if you look at the items on a measure, then do those, if it's a depression scale, do those items, to your knowledge, to what you know about depression, do those look like they measure depression? And if they do, then you have face validity. Content validity. To what extent are the questions or items a representative sample? If we developed a depression inventory and of the DSM definition of depression, we only included 3 or 4 of the dimensions of depression, let's say appetite or sleep, mood, but we excluded other dimensions of depression, then we would say our measure had low content validity because our questions or items was not a representative sample of depression, of that construct that we're trying to measure. Criterion validity. Criterion validity. To what extent does the measure predict performance or status? Predictive criterion validity looks at criterion measured in the future. So let's say we want to look at the predictive criterion validity of the SAT or maybe the ACT. So we want to measure that against what it's supposed to predict in the future. Well, what are SAT and ACT scores supposed to predict in the future? They're supposed to predict success in college. So success in college is measured mostly by GPA. That would be a measure of success in college, academic success in college. And what we know about SATs and ACTs and GREs, that these standardized tests actually have pretty low criterion validity. And that's, for example, this program, you notice that it wasn't a requirement that you took the GRE to get entry into this test, because we didn't think that the GRE would be a good predictor of whether or not you would be successful in the program or a successful social worker in the future. Concurrent criterion validity. That looks at criterion measured about the same time. There is a scale called the CBCL, and it's called the Child Behavior Checklist. And for those people who work with DCS with children and measure children's problems may know of this scale. And it's a scale that's about 116 items. And it's very lengthy to fill out. And that's one of, it's a very well-regarded scale. It's considered the gold standard in measuring child behavior problem. It's been around a long time and considered the gold standard, just like the Weckler IQ scale is considered the gold standard for measuring IQ. So, so we have this CBCL, but one problem we have with it is that it's long, and DCS doesn't like using it because it's long. So Dr. Charles Glisson approached DCS, or DCS approached Dr. Charles Glisson at UT to see if he could come up with a shorter measure that would essentially give them the information that they used from the CBCL. The CBCL was, had probably a total of 10 subscales, but essentially they used the two subscales, one that measured externalizing behaviors, acting out, and one measured internalizing behaviors such as depression, anxiety, those kind of things. And so Dr. Glisson developed a measure. I believe it was about 40 items, and he then, in order to test the concurrent criterion validity of his short, I think he called it the short behavior checklist, CBC, what he did was he measured, he gave to the same people, and maybe let's say it was 100 parents, both checklists. And he might have balanced, giving, for order, maybe gave half of them the CBCL first, and the other one the CBCL, the second one, to worry about, to address order effects. But he gave them to them at the same time. And then he looked at the correlation between the externalizing subscale from the CBCL and the externalizing subscale for the short behavior checklist that he developed. And he did the same thing for the internalizing subscale. And what he found out was that he was able to measure these constructs using fewer items, much fewer, should say much fewer, using fewer items. So he was able to use 40 items instead of 116, and DCS found this to be a lot less burdensome on their clients, and were able to use it with their parents a lot easier than the Achenbach, the CBCL. Okay, that's an example of concurrent criterion validity. Known groups validity. Let's say that we have developed a eating disorders inventory, and let's say it's a 25 item eating disorder inventory. Well, we want to establish known groups validity. So we give it to a group of people we know have eating disorders. So we go to a large facility, and before people get treated for eating disorders, maybe shortly after admission, they're given this new eating disorders inventory. Okay, and we collect 50 of those. About the same time, we go to Science Hill and collect, and these were all females, and then at the same time we take a random sample of 50 girls around the same age as the girls surveyed at the eating disorder clinic, and we give them the same scale, okay? And we have no reason to believe that they have eating disorders. You know, there might be a low percentage, you know, whatever the percentage in the population that have eating disorders, probably, you know, there may be a very low percentage of these young girls at Science Hill that have some form of eating disorders. But in general, we think that's very low. So we take the scores from the Eating Disorders Clinic and correlate them with the Science Hill sample, 50 people from Science Hill, correlate those, and the correlation comes back 0.12. Is that good? Yes, it's very good, because that means they aren't correlated, meaning because if the correlation had been high, if it had been 0.7, 0.8, then we would worry about what we were measuring. Are we measuring eating disorders? Are we measuring teenage angst? Or whatever. So that's an example of known groups validity. Okay, construct validity looks at to what extent does the measure correlate in a theoretically predicted manner with other constructs, such as convergent, construct validity. Let me back up a minute. To what extent does the measure correlate in a theoretically predicted manner with other constructs? What does that mean? All that means is that it should correlate this measure. Let's look at, say, we're trying to establish the construct validity for a new depression scale. All we're saying is this new depression scale should correlate with things it should correlate with, either negatively or positively, and it shouldn't correlate, so it should correlate close to zero with things that it shouldn't correlate with, okay? So let me take your paper and write depression in the middle. Okay, and around it, write anxiety, self-esteem, IQ, and I have one other, and age. And we're going to sample people from 18 to 65, so that's the age group that we're looking at. Now we're going to look at the relationship between depression and anxiety, and we find that there's a high correlation. So, and then we look at then we look at the relationship between depression and self-esteem, and we find a negative high relationship, a negative 0.62. And between depression and anxiety, we find a positive 0.73. And so those two demonstrate convergent construct validity, because you would expect depression to be related to anxiety and self-esteem, because they correlate either positively or negatively. Okay, let's say you look at how depression correlates with IQ. It's 0.04. And then how depression correlates with age, it's 0.10. So these are close to zero. So these demonstrate discriminant construct validity, because there's no reason, there's no theoretically predicted reason, there's no theory that depression should be correlated with IQ or with age. Now, I said age between 18 and 65. There is, indications of elderly people having depression. So that's examples of convergent and discriminant validity. Finally, sensitivity to change. Let's say you're a clinician, and every week, clinician number one, Sam, asks every week, from 0 to not depressed, 1 moderately depressed, and 3 highly depressed. 0, it's hard to do this without a board. 0, not depressed at all, 1 moderately depressed, and 2 severely depressed. And that's Sam. And then Terry, our second clinician, gives a BDI every week, a standardized scale that, let's say a generalized contentment scale that ranges from 0 to 100 every week. And she gives that every week and gets the scale from 0 to 100. And the question is, the concept sensitivity to change has to do with, is your instrument sensitive to change? Well, Sam's instrument is not very sensitive to change, because somebody could come in for weeks and say they're moderately depressed. Whereas Terry could see, how depression on a scale from 0 to 100, the standardized scale, undulates, up and down, hopefully down, if her intervention is successful. So that is more sensitive to change, Terry's measure. The relationship between reliability and validity. Well, as we saw before, starting with the last point, validity, if all those things hit the bullseye, validity implies reliability. If something is accurate, then you apply reliability. And in the same vein, reliability is a prerequisite for validity. In order to have validity, you have to have reliability. You can't have validity without something being consistent, a measure being consistent. And lower reliability, if something is less consistent, then that leads to lower validity. So that's the relationship between the two. Factors influencing reliability and validity. And we're going to go through this over and over and over again, but there are ways to maximize reliability and validity, and some of the most important are administrative procedures. It's important to have things in the same settings, the same environment, the same administrators, the same instructions, and the same time. If you vary those, you give your instrument, in a very loud lobby one week, and then in a quiet office the next week, that's going to influence the reliability and the validity of the scale, because the change that you see, you don't know, is that due to the change in setting, or is it due to the change in my client's depression level? Populations vary by age, gender, race, sexual orientation, ethnicity, geographic area, socioeconomic status, education level, religious affiliation. So we're talking about diversity here. And not surprisingly, most standardized scales are not developed using very diverse samples. So it's important to understand how how the scale was developed, what the population was in terms of these factors, in terms of these population factors, and then make a determination, well, is this biased by age or gender or race, sexual orientation, ethnicity? Just because it wasn't tested with it isn't, but it certainly is important to look at the items and at least make an initial determination that way. But that's another thing that can influence reliability and validity, because things can be biased. We've heard of IQ tests being biased by gender or race. It's the same thing with standardized scales that affects the reliability and the validity of a lot of factors to consider. And we as social workers, many times we're dealing with diverse populations, and we want to make sure that the measures we use are accurate. So if you have any questions about whether the measure that you're using is accurate, if it's biased by age, gender, race, sexual orientation, etc., then perhaps you should put together some what are called individualized rating scales, or have them log their problems, or use different methods. Well, I think we're going to use different methods anyway, and then compare and see if those factors are different using different methods. Okay? End of chapter 2.